emission scenarios. What are emission scenarios? Emission scenarios are assumptions of how much CO2 and other greenhouse gases will be emitted into the atmosphere per year in the future. Okay, I just showed you one example of what happens if you keep CO2 levels constant, or if you kept them constant from, say, 100 years ago. Okay? Now we have a look at what happens in the future. So you have to make assumptions. And that's what we call emission scenarios. Okay? And here's one example from the fourth assessment report of the IPCC. Okay? The fourth assessment report, and the names that they used. Okay? So here's one example, okay, of emission scenarios. And this, we're talking about emissions from fossil fuels and cement. We're talking about CO2 in this graph. Okay? So you can see historical emissions, and then there are different pathways. And the one which has continued increases in CO2 emissions until the end of the centuries, in terms of gigatons CO2 per year, up to 100. This one is called RCP 8.1. Okay. RCP 8.1, and what it means is it's called a representative concentration pathway. Okay. It's a greenhouse gas concentration trajectory adopted by the IPCC, and that number here, the 8.5, actually stands for a radiative forcing anomaly in watts per square meter. That's where these numbers come from. The bigger the number, the higher is the radiative forcing anomaly. Yeah? And what you also can see here in the colors is the projected change. Okay, this is the average, global average temperature change. For this scenario, 3 to 2 to 5 to 4 degrees Celsius. Okay, relative to 1850 to 900. And then you have other scenarios. You have one scenario which is called RCP6, okay, and where you get a change up to between 2 and 3.7 degrees Celsius, and you get that variation because that's what different climate models predict. Yeah, it's ensemble modeling, and you get a certain range. And then you have scenarios where you assume that the CO2 emissions drop rapidly, from 2020 already, and you get a zero emissions, okay, in about 2075 or something around that time. Okay. And that corresponds to a change. This is called RCP 2.6, and here the temperature changes between 1 and 2.3 degrees. Okay, and these scenarios have been based on different assumptions about population, economic growth, energy consumption, and sources and land use over the century. Again, you can see here in the table, it's based on the primary energy use. You can see lists like solar, hydro, bioenergy, nuclear, natural gas, oil, and coal, and different proportions allocated. Yeah. So these are the different, an example of emission scenarios that have been used in past IPCC in the modeling used for these reports. Okay. All right, so what are the new emission scenarios of the latest IPCC report? And they are shown here. They are called now SSP, Socio-Economic Pathways. And again, we can see that there are scenarios, and starts in 2015. There are scenarios where this is for carbon dioxide here on this graph, where the emission increases and then stays at a high level. You know, this is called, again, the numbers correspond to, radiative forcing anomalies here at the end. But you get some new scenarios, there's actually one where emissions drop to zero by 2050, assumed. But what's also included here are also scenarios for other greenhouse gases, like methane. You can see here the assumed behavior, assumed changes, nitrous oxide, and other contributors to aerosols. So here it should be noted that scenarios, the 8.5 scenarios, are similar. The new ones and the old ones are similar. Okay, and the 2.6 scenarios are also similar. Okay, so now you use these scenarios, and use them in your climate model, and you predict the future climate conditions on Earth for each of these scenarios. Okay, and then all the predictions are put together as ensemble predictions of different climate models, and that's the ensemble forecast. And this is already the end of the second part of this lecture, and we have a look at these forecasts now. How do the forecasts look like?